All right, who wants to learn about CI/CD? There we go. All right, so just a real quick introduction about myself. Worked at Vanguard for nearly 12 years. I've had a multitude of different positions at the company. A couple of years ago, I stood up here at SauceCon and gave a talk about how to remove flakiness in Selenium tests. I mentioned that we were working on open sourcing that framework. Proud to say today we've done it. It took nearly 2 years, but it's open sourced. So if you want, you can go back in time, view that talk on YouTube, and go down to the open source link down there on the slides. It's available for use for the Java framework, so good news story there. But we're here to talk about CI/CD and our journey for how we got there. There are a number of steps in our journey. Hopefully a lot of them will resonate with all of you. I'm sure you're somewhere within one of these steps, and hopefully we can help you move all the way to the right to where we are and where we're continuing to go at Vanguard. So our journey starts in the Middle Ages of testing. Our tool of choice was basically Microsoft Excel. We had user actions and expected results, and teams worked on projects for 6 to 9 months, after which they dump all of these manual test cases that they wrote into this thing called a regression suite. And a regression was basically thousands of manual tests, right? We had about 100 or so testers working year-round, continually writing these manual tests and dumping them into regression. And clearly, that was not going to be sustainable. So we thought, all right, well, what can we do? We entered this, entered this age of the Renaissance where we said, all right, manual testing isn't going to work. We got to try something. We got to keep trying stuff. So we quickly tried this Mercury Quick Test Pro, or QTP as it was called. We hit this record button. We recorded all of our manual scripts. We went through regression on the same release that the scripts were recorded, and 95% of them failed. So we weren't quite there. So we kept trying new things, and eventually we found this tool, Selenium. Selenium 2, I think, had just been released about a year or two earlier. It's still relatively new. But for the most part, it solved our problems for trying to automate tests. We spent a lot of time and effort into this framework that I mentioned earlier. It got rid of a lot of the flakiness in the tests. And for the most part, it kind of pushed us along, right? We went from a feedback that was once a quarter when we would do quarterly regressions for our quarterly releases to basically a feedback loop that was kind of like overnight, right? We would run all of our scripts once a day, and in the morning, people would come in and see, hey, my test case failed or my test case passed. And so regression moved from thousands of manual test cases to thousands of Selenium test cases. We kind of took this like one-to-one approach, right? If you have a manual test, let's automate that manual test. We saw that this wasn't really going to work either, right? Let's pretend we live in a fantasy world where flakiness is a thing of the past and doesn't exist at all for any test ever. Having thousands of Selenium tests in your regression bed is still not where you need to go, because thousands of Selenium tests means probably tens of thousands of page objects. It probably means millions of lines of code, and maintaining that is just going to be a nightmare, even flakiness all aside. So we gotta continue to adapt, and the Renaissance wasn't quite enough. So we move on to this age of enlightenment, AKA shift left, right? We've all heard that term in the industry. It's about moving tests lower in the pyramid, following that testing pyramid, creating unit tests wherever you can. If you can't solve your problem with a unit test, create an integration test for it. And an end-to-end test should be really like the last option that you're going to choose, right? So we end up with this regression of a mix of unit and integration and end-to-end tests all kind of bundled together to give us the security and the confidence that we need to be able to elevate our code to production and know that it's going to be bug-free. And this is really good, and it works well for these monolithic applications, right? If we're going to have a monolith application and we're going to have these monolithic releases, we can spin that giant monolithic application up in an environment and go through a mix of unit and integration and end-to-end tests and test that release out before we release it to production and know that we're going to be good. And while this is good, we're also moving into a new direction in the software development industry, right? We're no longer developing these monolithic applications. We're moving on into a better and brighter future. Enter the age of the microservice, right? Rather than developing these large, giant, monolithic applications, we're thin slicing them. We're developing very, very small services that do one thing and one thing only, and then we combine all of them together into this mesh network of API services in order to generate the functionality that we need. What this means, because it's a fundamental shift in the way that we're designing and developing software and releasing applications, we need a fundamental shift in the way that we think about how we test those applications. So no longer can we rely on this unit integration end-to-end kind of mentality where I'm going to write some Selenium script to run through my entire application in its entirety. That doesn't really make sense in a microservice API economy world. So what we really care about is getting to CI/CD. How do we get to continuous integration, continuous development? And the key there is to have your regression be all the test cases that you need to gain confidence that I can elevate my code to production bug-free and have all of those test cases run within the build of your application. So how do we get there? First, I want to level set and explain what I mean when I talk about this API microservice economy world. Let's pretend that we own Microservice, and Microservice depends on a number of different downstream dependencies, right? We got other service, third-party service, all the way down the line, and who knows just how far this tree extends all the way over. What we care about, what our job is as the owner of Microservice, is testing what's in the box. Anything outside the box is someone else's job to take care of and make sure that it works. But our job is to test what's in that box for Microservice. So we definitely want to unit test all that stuff, but there's these things coming out of Microservice that are also, in large part, our responsibility to test, which are the external dependencies and where we're making those calls to our downstream dependencies and our downstream services. So what we need to do is unit test our stuff, right? That still applies. So when we go back to our traditional methods of thinking, we have unit tests and integration tests and end-to-end tests. We definitely still want to unit test. Unit test gives us a lot of that confidence that given perfect mocks and perfect objects that come back from our downstream jobs, we know that our service is going to work correctly if we get that. And that's what unit tests allow us to have that confidence. They also run extremely fast, which is great, right? Order of microseconds. So we get that super speed, but where they lock in is that full end-to-end confidence, right? We know given perfect objects from our downstream jobs that our system is going to work right. But what's guaranteeing us that the mocks that we create for our unit tests are actually what the services are going to provide? Well, if we just unit test, there's really nothing that gives us that guarantee. So we've got to go a step further. And traditionally, how we kind of got that guarantee was we moved to something like an end-to-end test, right? Let's take all of these downstream services and our service, throw them up in a region somewhere. We can run through it completely end-to-end, from system all the way down to database, back to system again. And now we have our end-to-end confidence, right? We know our system's going to be bug-free. We can elevate to production, no bugs. I know there are going to be no bugs because I got these end-to-end tests that cover everything. The problem here is that the end-to-end tests, especially in an API microservice world, are extremely costly to set up, right? You got to figure out what all of your different downstream dependencies are, throw them all up in a region, get them all running and started, and not only that, but you got to maintain this kind of configuration of how to set this stuff up, not only in production, but now in a test region too. So they're very, very costly, and even more than that, the speed at which the end-to-end tests run, right, are orders and orders and orders of magnitude slower than a unit test. So while they give us this great guarantee that all of our system is going to work completely end-to-end, we have a lot of trade-offs there. There's cost and speed trade-offs in order to get that kind of guarantee. And last but not least, we kind of take this approach of an integration test. It's kind of like the best and worst of both worlds, right? Now, the good thing about integration tests is we can kind of choose which services are going to be included live in our integration test and where that mock endpoint is going to fall, right? So maybe we include just our service and our direct downstream dependencies in a live integration test and everything else we mock. That's relatively fast. It's kind of almost on the order of unit tests. But maybe we include everything all the way down, all the services down to the database. We just mock out the database call. That's more like an end-to-end test, right? So we get a lot more confidence that things are going to work all the way down the line. But again, we go back to that trade-off of speed because we're loading up more and more services, and it's more costly to do that kind of thing. So we end up with this kind of scale where you can pick any one point along this line with traditional testing. right? You can either get confidence or you can get speed, but you can't get both. Now you could pick, maybe you want like something that's somewhere in the middle, and in that case you could pick an integration test and pick anywhere along that line. But what we're really after in testing these microservices is to get to our ideal, right? We want speed and confidence. We want them both. And traditional methods of testing just don't quite cut it. So what's the answer? Well, the best answer is contract testing. I'm going to give you some examples using PACT. It's a consumer-based contracting testing tool. And PACT really gives us both that speed and confidence that we're looking for. It's kind of a paradigm shift in the way that we think about testing, but it's an important one. So I mentioned contract testing a whole bunch of times now. It's kind of the theme of the talk. What does contract testing really mean? Well, let's pretend that all of you in the audience are writing your own web apps, right? And you're trying to put weather information up there for your clients on a web page somewhere. You care about temperatures and humidities and all that kind of stuff. And I have a weather service that I've created. And it's got an endpoint called Get 5-Day Forecast. Well, when you call my service for Get 5-Day Forecast, I'm going to return you some kind of data, right? Maybe it's an XML object. Maybe it's a JSON object. What does that JSON object contain? What are the properties of it? How does that object look? Well, the format of that object is the contract that you and I are all agreeing to and testing to make sure that when you make the call to Get 5-Day Forecast, I am going to return you the object that we both agreed upon. We both have a contract that I am going to supply you, is what we're talking about when we talk about contract testing. Right? It's about giving that guarantee that when you mock the endpoint for Get 5-Day Forecast in your unit tests, and you have that mock object, that what I am returning to you is going to match exactly what you've mocked, so that you can get that guarantee and that confidence that you're able to deploy just by running your unit test and by running this PACT verification. So how does this look in practice? Let's pretend that this is our API service world. You all have this web app that you're looking to create and test. I have this weather service, and because it's an API economy world, I'm dependent on other services, right? I don't make this data up out of thin air. I get it from other services down the line myself. So when you run your builds for your weather web app, you're going to run all of your unit tests, right? Because unit tests are important. We all unit test. And we're going to use PACT as our mocking framework. So when you run your unit test and you call Get 5-Day Forecast from my weather service, you're going to create this mock that says, I expect object X to come back. And I'm going to use that in all of my test cases. And given that object X comes back and I know the properties of object X, I can make sure that all those properties display on the right times at the right places on my web app. So you run your build, and your build goes green because all your tests pass. And because you've used PACT as your mocking framework, you end up creating these PACT files. And all these PACT files really boil down to, at the heart of it, are a list of URLs and expected response objects that come back from those URLs, right? It's what you mocked. So your build is going to take these PACT files, and we're going to put them somewhere. We're going to make them live on a PACT broker. It's just a server somewhere that stores out all the PACT files, so we have one common place for it. We can manage it and all that stuff. The very last thing that your build is going to do is going to be to call any downstream dependencies that you have, and we're going to build their project too. Remember, these are microservices, so they should be relatively small and relatively stable. So it's going to have a downstream job to call my weather service and build me. The first thing I'm going to do is go out to PACT Broker and say, hey, broker, give me all the PACTs for all the people in this audience that have all created web apps that all use my service, and give them all to me, and I'm going to run these PACT verifications as part of my build when I run my unit tests. So my build is going to start up my server. It's going to start up my service, in which case I'm going to have a live call to Get 5-Day Forecast, and I'm going to run it for each of your PACTs, and I'm going to verify that what you expected in those responses that are in those PACT files actually comes back from the live server call that's going on because my system is up and running in an environment somewhere during my build. So with that, my tests go green, but they go green in large part because I'm running my own unit tests that are dependent on meteorology service and vendor service as well. So I have my own PACTs that get generated back to the PACT broker as well. Now, Once we've done this step and my build goes green and I've sent my packs down, we know that the integration between our two builds is good to go. But we only know that because I've mocked out services on my end. So what's guaranteeing that those mocks are actually what's going to be returned so that I can guarantee what's going to be returned to you? Well, we kind of continue along this step, right? So I run my downstream dependency jobs, and meteorology service goes, and its build goes green. And because it's not dependent on anything else, it knows, hey, my build is green, all my dependency jobs are green, because in this case I have none. That means that the integration between weather service and meteorology service is good to go, which means that meteorology service says, I can deploy my stuff to prod and know that there aren't going to be any issues, because my build is green, and everything I'm dependent on is green as well. And we've verified all this stuff through PACT verification. I say, that's great, but I have another downstream job, so we're going to kick off vendor service as well. Vendor service is going to grab my packs, and we go through the whole step again. Vendor service goes green. Now that comes back to me as weather service and says, hey, all of your downstream jobs are green. I know I'm green, so that means I'm good to go. And then I can convey that message back to your build, and your build says, hey, I'm green. All of my downstream dependencies are green. I know I can deploy too. And that's how we get to this world of both relative speed and extreme confidence, right? We have virtual end-to-end confidence here, because even though we're only running unit tests all the way down the line, at each phase in the line, we're verifying that the mocks that were used for the unit test before are actually what's going to be generated from a live server call as the service is actually running. So that's really great. There are some downsides, obviously, to PACT as well. You may say a relatively big one is that you're dependent on all these downstream jobs, especially in this API economy world. That list of downstream jobs can grow pretty heavily. I would say that one kind of mitigation to that is that we're talking about microservices, micro being the key phrase there, right? So these services are small. We're only running their unit tests so that each of these builds should be relatively fast. And because we're in a world where we live on version control, we're only running these builds on master to do these PACT verification checks. And so the build should be relatively fast, relatively stable. And so while yes, you're dependent on all these downstream jobs, and maybe this version of PACT isn't the right way to go for you. We'll go over another one in a few slides. It can be mitigated to some extent. Now, the other thing with PACT is that it's a consumer-driven contract testing framework, which means that we actually allow consumers to break provider builds. And what I mean by that is, let's say you write some test in your code that says, hey, I'm going to call Craig's get 5-day forecast method, and I'm going to expect object Z to come back. And you throw that in your code and you build your project is going to build just fine, and you're actually going to generate a PACT file that lives on the broker that says when I call 5-day forecast, I expect object Z or Z to come back. Well, when you kick off my build as part of the PACT verification, my build is not going to fail because I didn't implement object Z. I implemented object X, right? So now we have a clash, and the services kind of break down a little bit. You got to work your way out. Why do you expect object Z? We agreed on object X. That was the contract kind of thing. What this does allow you to do on branches, which is a little bit more complicated and more time than I have to get into in this 35-minute talk, but what you can do is utilize those branches to actually request new features, right? Let's say you come to me and say, hey, Craig, we really like this get 5-day forecast method, but our clients actually now are looking for get 5 days or 7 days. They want that option. We want a new feature. Well, I say, hey, great. Create a branch, call it get 7 day, and you can decide exactly what object you want me to return to you. You get to decide, because you're our clients. You make up your minds on what you want. You generate that PACT in a branch. It will fail, hopefully, a branch in my build. And now we actually have a method to say, once I and my team implement that get 7-day forecast method, we know exactly what we need to implement, right? We know the URL, and we know the object that you guys expect to get back. And so me and my team creating that new feature becomes relatively straightforward. We've actually implemented TDD, right? You guys have given us the test that we need, so now we just need to go and implement it. And as soon as we implement it, you guys are actually notified because you have a build that's going to say, hey, this build is now passing because the service downstream has now passed and implemented the PACT. So it could be a useful feature. But again, if you're looking for more information on exactly how that would work with branches and tags on the PACT Broker, you can come see me after the talk. So let's go back to our PACT on the sliding scale. We have our traditional testing of unit and integration and end-to-end tests, and we said we could pick a point on this graph of either speed or confidence. Well, if we go back to how PACT Broker works, right, we actually get virtual end-to-end confidence because we're actually spinning up all these services independently, hopefully in some kind of parallel form so that the builds still go pretty fast. But we're actually starting up these services and actually verifying that the mocks are what's going to match the actual live service call. And all we ever did was run a whole lot of unit tests. So we get both speed and confidence. You might say, hey, that's great. We talked about a second way of implementing PACT. What if we take this same kind of concept and said, is there a way that I could sacrifice just a little bit of confidence and gain even more speed? Something that looks more along the lines of that. The answer is actually yes. So we can get to PACT Swagger validation, which is the second way of implementing PACT, in addition to our PACT Broker. So Swagger, for those that are not aware, is becoming an industry standard. It's basically a spec document that lists out all of the URLs that your microservice has to it, what the parameters to those URLs are, what the values to those parameters might be, along with the objects that are going to be returned from each of those URL calls. A lot of times there's a lot of description around like why the objects look like this and other kinds of like free-form descriptions and stuff like that. But Swagger's quickly becoming an industry standard that most services are starting to adopt as a way of documenting what their system and what their service does. We can actually utilize Atlassian's PACT Swagger Validator and Swagger Mock Validator for both Java and JavaScript to actually implement PACT verification at a much simpler, much faster method. So let's go back real fast and kind of overcap how the PACT Broker flow works, right? You guys run your web service or your web app build, and that creates PACT files that, again, have the URL that you're trying to call and the mock object that you're creating from that call to satisfy all of your unit tests and that all of your unit tests can pass. We put that into the PACT Broker. I run my downstream job from the PACT Broker. We verify that our integrations are right, but only because I generate my own PACT. So then we keep going down the stream, right? Each build runs. Each build runs successfully. Each build knows that they can deploy to prod without any problems. I know I can deploy without any problems, and then you know you can deploy without any problems. It's a relatively long-winded approach, but again, it's kind of the only way that we get to that full end-to-end confidence. So what do we trade off that confidence just a little bit and try to gain more speed and efficiency? And so we could actually implement with Swagger. And with Swagger, one of the key downsides, if you want to call it a downside, is that we enforce that every service provides their Swagger definition, right? They have to both supply it and make sure that it's maintained, because that's key. Once each service has and supplies and maintains their own Swagger definition file, when you guys run your web app builds, the first thing that you're going to do is pull that Swagger file from all of your downstream dependencies into your build. Right? In this case, you only have one. You're only dependent on me for the weather service. But if you had a list of them, you would just pull in all of them. Then, when your unit tests run, instead of generating these PACT files like you did before for the PACT Broker method, we already have a document that says what the endpoints are and what the expected results are going to be from calling those endpoints. And if you remember, that's basically all that's in the PACT files, right? Are the endpoints and what objects you expect to come out of them. So now when you run your test and you do the PACT verification within your build, solely within your build, you're actually just taking those PACT verifications that are getting generated from the PACT mocking framework and comparing them to the Swagger files, excuse me, directly to make sure that for each endpoint that you're calling and mocking out an object for, that object exists exactly how it exists in the Swagger definition for how the service would provide you that object. And thus, we get to a much simpler, much faster flow because you know that you can build as soon as your project is done, as soon as your build is done for your project. So what are the pros and cons on this PACT Swagger validator versus the PACT Broker? Well, obviously, this flow is much simpler. It's much faster, right? All you're doing is running your unit tests and your PACT verification on your own build. You're not dependent on any of the downstream jobs at all, which is nice. So one thing about the PACT Broker, because you're dependent on downstream jobs passing, and because through consumer-driven contract testing like PACT, you actually have the ability to break the provider's downstream job. There's virtually no way that you're going to get a vendor to agree to running PACT through the PACT Broker, right? No vendor is going to say, yes, we will allow you to break our build. That sounds like a good idea. So PACT, the Swagger validation gives us this method that even with vendors, they should happily agree to provide you a Swagger definition file, right? That's just a documentation file that says what their service is doing and how it works. And if vendors don't agree to giving you a Swagger file, I would suggest, use your purchasing power. Tell them, look, this is what we need in order to verify that our stuff is not going to break in production. And if you guys are not willing to provide us with a Swagger file, maybe we will look somewhere else for someone that will. So PACT Swagger gives us this really fast way of giving us our confidence. The downsides to Swagger versus the PACT Broker, right, we're losing that little bit of confidence. We're no longer actually executing live calls on all of our downstream jobs. What we're doing is relying on the fact that the Swagger definition is actually what the service would be providing. So it's key for the service providers to make sure that that Swagger file is maintained very heavily. There are ways of mitigating this, actually. So there are tools and practices and annotations that you can use that'll actually generate or auto-generate Swagger definitions for you to basically make sure and ensure with a virtual guarantee that the Swagger definition is going to match literally what your service is providing. So some of those cons we can mitigate if we choose to auto-generate the Swagger file itself. So I'll leave you guys with this summary. CI/CD is all about automating at the lowest possible level, right? We want to try to get those unit tests. And remember, it's all about writing unit tests and then verifying that those unit test mocks are actually going to be what the service is going to generate. And once we do that, we've satisfied our testing condition that we need for our system, right? If we unit test everything, the only downside is that the mocks aren't guaranteed. So if we can guarantee the mocks also, then we're done. Traditional end-to-end style and integration testing has much less of a place in this microservice API economy world, right? We don't want to start spinning up like downstream service after downstream service after downstream service, all in the same environment with all the configurations and stuff that would have to go along with that. It's timely, it's costly, and the unit tests run much, much faster. So we want to try to get away from that old mindset of thinking and move more towards contract testing, which I believe is the future of where we need to go as an industry. Traditional testing has this sliding scale between confidence and speed. You only get to pick 1 point. But contract testing with things like PACT allow us to kind of pick 2 points, right? We get both the confidence and the speed. And with that, I'll open the floor up to any questions. Thank you. Can we lower the lights a little bit? And I don't know if we have a mic to go around for questions.
Yeah. Are there any differences in implementing that when it comes to using the traditional like microservice architecture and RESTful architecture, or using like something a little bit newer like GraphQL? And is it possible to implement PACT in the GraphQL environment? And are there any challenges doing that?
So I'm not really familiar with it, but I do know that the Atlassian PACT Swagger validator will work for both Java and JavaScript. So it should fit into those paradigms. I know I've run into another couple of people asking for things like for like XC test on iOS apps and stuff like that. I don't think contract testing is quite matured to that level yet. So I'm sure there are frameworks out there that PACT testing you're going to run into a lot of challenges of trying to like integrate this thing in there. But I do think that it's growing, and it's something that's going to continue to grow.
Hey, it's not a question, but we're here.
Yeah, I can't see, the lights are a little blinding.
Anyway, it's not a question. So you had one of the slides that had the URL for the open source Selenium framework?
Yeah, the opening slide, yep.
Yeah. So I just need that. Yeah, thanks.
Yeah, you can request the slides. I'm sure Sauce Labs will have a way of having us presenters give the slides out to them, and then I'm sure they can reach out and provide them all to you. Yeah, I got a bunch of animations in here. Whoops. There we go. Yeah, it's github.com/Vanguard, and there's only a couple of things that are out there.
Cool. I have one question here. How do you manage your API versions across here?
Yeah, API version is a great question. So this talk is only 35 minutes, and I wanted to make sure that I had some time for questions. So the demo looks super slick and nice around like how PACT Broker works. When you start getting into multiple versions of the provider and even the consumer, things start to get really complicated really fast. So if you're really interested, come see me after. I can't really explain it in the 4 minutes we have left. It's one of the bigger reasons that I actually like the PACT Swagger validator a lot more. It cuts down on this complexity completely. If you're wondering how the PACT versions, how PACT would work through versions with the Swagger validator, it's just a matter of the provider supplying multiple versions and keeping those multiple versions up to date for whatever they support. And then the consumer just needs to bring in the correct version of the Swagger validator. So there, things get super simple, right? It's very easy to see how that would work. To see how this would work, you actually need to implement things like branches and tags on the PACT Broker, and trying to keep the providers in sync with all the different versions of all the different consumers can get really complicated and hairy. It's something that we've spent a lot of time and effort trying to work around ourselves, and I still don't think even we're there for where we need to go for trying to implement PACT Broker that way. So it's one of the reasons that I tend to lean more towards the Swagger validator for most things. But again, there's pros and cons to everything, so you gotta pick what's right for you. Any other questions?
Yes, I have one. What did you do with provider status? For example, if you want to test something and we need provider to have a specific state.
Sorry, can you repeat that?
What about provider status? Because PACT can test just perform one request and check response.
So you're talking about what about provider state?
Yeah.
Was that the question? Yeah, so it's a good one. For the PACT Broker, one of the pluses and benefits that you can get with it is you could actually, there are ways in the PACT Broker method to provide that state within your PACT file. So I kind of dumbed down a little bit what's in the PACT file. One of the things that can be included is state information. It's one of the benefits that you get with the PACT Broker approach that the Swagger validator actually won't give you any way of utilizing. So it's one of the pros to the PACT Broker that the PACT Swagger validator doesn't provide. The Swagger validator will only allow you to validate on an object's structure, right? So what properties are where, how does the object look? Is it an array? Is it an object of objects, and where are those properties located? And what are those properties named? And you can even do like whether those properties are ints or strings or dates or other objects themselves, which is most of the time, I tried really hard for a long time to think of a really good practical example of when I would need to validate a particular value within an object in a unit test, and that typically just doesn't happen, right? We care about that this property is a date, and then it comes in to the object where we want to know about it. The fact that the date is today's date versus tomorrow's date is not something that I typically care about in a mock, right? Maybe I write a unit test for that somewhere later down the line. So I think that the state information is a little bit less used, but if you need to use it, you need to utilize the PACT Broker approach, because that allows you to put that state information in the PACT files. Any other questions? We got time for maybe one or two more. Awesome. All right, I hope everyone enjoys the rest of the conference. If you'd like to talk to me about PACT or anything else, please feel free. I'll be around for the rest of the conference as well. Thank you.